Welcome to the 215th meeting of the New York Linux Users Group, the latest in our regular monthly meetings. Tonight we have Lennart Poettering, who will give us a talk about systemd in 2018. We all know Lennart as the creator of Pulse Audio and systemd. Tonight, before we get started, we have our usual requests. Silence your cell phones. Do not eat snacks and noisy wrappers during the presentation. Please use mics for questions so you can be heard in the recording. I'd like to thank Facebook for sponsoring this event and call out Tejin Heo for his help arranging sponsorship for Lennart's travel. I'd like to repeat our thanks to our regular space sponsor, 2 Sigma, and acknowledge our other sponsors past and present, Bloomberg, IBM, Canonical, Brandor Group, Google, and Pearson. In addition, NYLUG would not be able to function without our many volunteers who have contributed greatly over the years. We have a few announcements. Our next workshop will be Tuesday, June 5th from 7 to 9 p.m. Check out our meetup page for more information. The next general meeting will be June 20th at 2 Sigma and will feature Daniel Ryak, who will be giving us a talk titled A Graybeard's Worst Nightmare, an exploration of how modern Linux technologies like containers are shaking up the core traditions of today's GNU Linux operating systems and how we manage them. Please check out our meetup page for more information. After the presentation, we'll be heading to the Storehouse at 69 West 23rd Street on the northeast corner of 23rd and 6th for further discussion. We will be downstairs in the back. Right now, I'd call out to see if any audience members have any announcements.
Hi, I'm Patrick Ladd. I'm the organizer of the New York Red Hat user group, and I just want to let everybody know that our monthly meeting next month, June 13th, we're going to have Dan Walsh of SE Linux, and now our senior container strategist at Red Hat will be here to talk. So if you're interested, check out our meetup page. Look for NYRHUG. Thank you.
All right. Please hold off any questions until the end when we'll activate the mic and ask folks to line up for questions. Okay, on to the talk. Please welcome Lennart giving us systemd in 2018.
Hi. Does this work? Yeah, it does. Hi. Thank you for having me, Brian, and in particular Facebook for organizing this and paying for my hotel and everything. That's awesome. Actually, in contrast to what Brian said, I generally prefer the questions right away. So let's turn this into a little bit of a discussion, and rather than just me lecturing and then questions at the end. So if you have any question, completely feel free to interrupt me. I like that much better, and particularly because we can then make this talk go into the direction that you want instead of whatever I have prepared on the slides. I have a lot of slides, but I have not the intention to actually go through all of them. It's supposed to be just enough if nobody of you has any specific questions, then I'm going to return to my slides. But in general, yeah, it's not more than that. Yeah, let's get started. OK, so systemd at this point in time is, I mean, I hope everybody of you knows what it is. Does anyone not know what systemd is? Does anyone know what systemd is? OK, I assume that everybody does. But yeah, so it's very short, the System and Service Manager, and that's all there is to say, really, if you know anyway what it is. At this point in time, it's the core component of most Linux distributions, like the commercial ones, but also most of the community ones. There are a few holdouts, but in generally, yeah, systemd is everywhere. In this talk, I want to talk particularly about 2 areas, like recent feature additions that you might have not heard about yet, and what's coming next, like the stuff that we have been working on that's going to hit systemd. It's going to be merged in the next weeks or months. Yeah, let's jump right in. Like the first topic I'd like to talk about a bit about is cgroups v2. Cgroups, does everybody know what cgroups is? Does anybody not know what cgroups is? Like, okay? To briefly mention what cgroups is basically a kernel API, how groups of processes can be managed both for simple management, right, so that we know that they belong together, and for resource management, so that we can put resource limits on it, like give them a little bit more CPU than other groups and gives them a little bit less memory than other groups. In systemd, this is heavily used because the way we do service management, every service maps to one C group on the lower level. The other way is true too. If you have a C group in a systemd system, it generally is mapped to a systemd unit, which is our generalization of a service. C groups has been around for a while, and it's like the traditional interface C groups v1 is quite horrible. It has quite some limitations. Tejun is nowadays the maintainer of that, so he can tell you all about it. But he's mostly doing C groups v2. So C groups v2 is supposed to make everything better. From a systemd side, yeah, we did all the transitional work to make sure that systemd works on both the old and the new C groups API. What does it all mean? Mostly nothing, right? Like it's just a switch from one low-level kernel API to another. So in the ideal case, you wouldn't notice. It has a couple of effects, though. One of them is because C groups v2 and the development in C groups in general has been progressing. We nowadays can turn on a couple of features that we didn't used to be able to turn on by default, right? For example, very recently we turned on memory accounting in systemd upstream. So that basically means that by default now, even if you don't configure anything explicitly and you use systemd upstream, then you get memory accounting. So for every server that runs, regardless how many processes it will tell you in the system control status output how much memory it's currently using, right? So that's the major difference from what we had before, because much of the accounting that used to be there for C groups v1 or in the old days came at a heavy price, right? It made everything slower, like memory allocations became slower and the other stuff too. So turning them on by default is a big step ahead, because we came to the conclusion that it's nowadays the impact of turning this on is small enough to just say, yeah, let's turn it on by default. There's another thing, like what it effectively also will give you something called IP firewalling. We'll talk about that later. But yeah, even though in systemd upstream we're pretty much ready to turn to C groups v2 these days, because it's an API breakage on the kernel level, we can't do this without making sure that all the applications that people use that do use C groups v2 actually work. The big holdout there is Kubernetes currently. It doesn't appear that Kubernetes is going to switch to C groups v2 or have support for C groups v2 very soon now, which basically means that it's going to be difficult turning on C groups v2 in the most general distributions, because, yeah, Kubernetes is the big thing, and particularly for my employer. And if Kubernetes doesn't do C groups v2, we can't really, I mean, we couldn't ship Fedora or something with C groups v2 turned on by default if we can't run Kubernetes on it anymore by default. So yeah, it's a bit of a sad situation. There's a little bit of a deadlock. From the systemd side of things, the takeaway, though, is that we're ready, right? Also, I heard, like, at least Facebook internally has C groups v2 already, so it doesn't, like, matter for everybody what Fedora does, but for me, from an upstream perspective, of course, before we can make C groups v2 and tell people that this is the new default and you should totally use it, we have to have the testing in Fedora first, so that, yeah, we know that it works in general case.
Version 1 and 2 are mutually exclusive machine-wide.
So the question was whether C groups v1 and C groups v2 were mutually exclusive machine-wide. They are not necessarily. They are mutually exclusive per controller, right? So if you want memory accounting on C groups v2, you can't have it on C groups v1. If you want CPU accounting on C groups v1, you can't have it on C groups v2. In systemd, there are 3 modes of operation implemented. You can have the full C groups 1 operation, the full C groups 2 operation, and something in the middle called hybrid. In the hybrid mode, basically everything you get is C groups v1, except that you also get the C groups v2 hierarchy mounted without any controller, right? So it's kind of supposed to be something in the middle. I'm not sure how relevant that thing is, because it's a stopgap, right? Like in the future, we want to go C groups v2. So to me personally, I'm not sure I want to push people to using the hybrid mode very much because it's not gonna be the same. Like it's an API that we know if we push people towards that, then yeah, it's gonna go away a little bit later. So I'm not too comfortable with pushing to people. But then again, some people want this, right? Like so that they get cgroups v2 like features, but some of the features, but still get cgroups v1 semantics and full. Yeah, any other questions to that cgroup thing so far? No questions. One thing that cgroups v2 adds is per-service IP firewalling. So on the lower level, what it actually implements is BPF IP support. Like BPF has anybody not heard of BPF yet? Okay, there are a few people. So BPF is this awesome new technology in the Linux kernel. It's actually not that new. It's like, you know, if you ever used TCP dump, you used BPF internally. And TCP dump, everybody knows what TCP, does anyone not know what TCP dump is? Everybody knows, awesome, what TCP dump is. So TCP dump is, of course, this thing where you can do like specify an expression, and then it shows you all the network packets coming in on the machine and going out of the machine. This expression is internally translated to some form of bytecode, and that is the BPF thing, and that bytecode is uploaded to the kernel, and the kernel runs that in a virtual machine. BPF has been around for a long time, hence, like from the 1989 or something. It recently, though, became much more interesting because people started using for completely different ways. Like you can do system call filtering with that to build sandboxes. And most recently in cgroups v2, we have this support that you can install BPF filters for the purpose of firewalling and IP accounting per cgroup, right? As mentioned, systemd maps everything that it manages, all the services, as a cgroup. So because of that, we can hook up a new form of IP firewalling to that, and IP accounting, actually. So this basically boils down that you have IP accounting on every single service individually. Yeah? You can type system control status if that's turned on, and on some service, and then we'll tell you exactly how many bytes and how many packets were coming in and were going out from that specific service. And there's also firewalling, so you can basically say Apache shall be able to have access to this IP network, but MySQL shall not, or something like that. I think this is actually a major step ahead for firewalling, because traditionally, like for local firewalling, because traditionally if people did local firewalling in Linux, what they did is we're using IP tables. But IP tables lacks a lot of context because it doesn't have any idea about services. Right? So what it has an idea about is individual packets. So if you write a firewall with IP tables, you usually try to reconstruct the context of it by using the port number, right? You know that HTTP is port 80, so you write the rule with port 80, and then you hope for the best. This doesn't, like with modern protocols, especially things like BitTorrent and these kind of things, and pretty much everything else that's newer, port numbers became a lot more dynamic, right? So that it's not really possible to write an IP tables rule unless you use some magic packet matching stuff that matches BitTorrent, for example. If we now have IP firewalling that is per service, right, where you can say on the BitTorrent service that you have or on the Apache service that you have that it shall be able to communicate with this set of IP addresses, then suddenly this opens completely new opportunities, and I believe it kind of puts a lot of sense into local IP firewalling that we previously didn't have. So yeah, it's a big step ahead. It's, as mentioned, based on cgroups v2 and eBPF. You only get it if you run cgroups v2. If you don't, you won't get this. It's exposed towards the administrator by this very simple option, IP accounting equals yes. If you set that in a unit file, then it's turned on for that unit file, for that unit, and you get proper accounting, and you do get the firewall if you actually specify rules. The rules you specify in a syntax like this. You basically say IP address allow, and then you specify some subnet, and IP address deny, and specify another subnet. If you combine these two lines in one unit file, you basically said, yeah, you whitelisted something there. It's very simple, very obvious, I think, in many ways. And to me, it appears like it's a major step ahead. I'd like to demo something on my laptop now. Can we switch to my laptop? So let me.
Make it bigger.
That's the biggest I can make it. I hope you can see that. So what I want to show here is like systemd. I hope you know that like there's not just the static unit file definition way, how you basically write a unit file, drop it into etc systemd unit, and then start it later. But there's also systemd run. Systemd run allows you to create transient units. And in systemd speak, that basically just means that instead of putting a static file somewhere, you can put together units on the command line, right? So systemd run -t/p bin bash basically says, run a unit now. The -t basically means that you get a TTY, like an interactive TTY towards the process. The bin bash means .bin bash. And then with -p, you can specify all the properties that you would normally write into the unit file just on the command line, right? So you can use this IP accounting stuff now to basically run a bash instance. Let's do that with sudo so that it's a lot less magic. So now I'm running this as a transient service. It got this name there. And whatever I do now, let me, by the way, tweak that a little bit so that we actually get the output afterwards. I got this interactive shell now. I can do whatever I want here now. I don't have network here right now, but I can communicate on localhost. So let's do this. Like we generate a couple of packets, and then do this. And then we see here at the end, it ran for 15 seconds, and it generated traffic for 252 bytes, right? Those are my ping packets. So it's incredibly useful to combine these transient unit stuff with the IP accounting. Of course, oh, that was not my thing. Of course, we can do the same. Wow, that font is tiny. I can do the same thing, actually, with the IP firewalling stuff. So let's... What? That is just weird. We can do the same command again. And this time we use IP address deny. Let's say like this. And we want to run a bash. So I got this shell again, and now I set an IP address that just applies to this one process and whatever it forks off. So we execute this again. So this IP address, of course, will match against this subnet route. And there we go. We get operation of permitted, right? So this is incredibly awesome because you can just, like, you have some command line. You can use systemd run and have a completely dynamic firewall for a set of processes. You get accounting. You get all this awesome stuff. So yeah, it's a really, really useful feature, and people should start using that. Any questions about the IP firewalling so far? I hope everybody got what I was showing here, right? There's a question.
Any prospect that this might be useful for desktop applications?
So the question was regarding whether there's any prospect to make this useful for desktop applications. So I'd love to make that, but it's, I guess, up to the kernel people, because currently this is a privileged operation. And if you, for the desktop, you want it to be accessible for unprivileged processes, I think there is no systematic reason why it should not be available to desktop, like to unprivileged processes. It's just that the kernel people so far have been afraid of that. I mean, BPF has the reputation, like there have been a couple of exploits, in particular with the processor bugs, right? Like the Intel bugs there, because it's a VM and then you have the security boundary in between. So it has a bit of a reputation that it might be dangerous. So the kernel people so far have been afraid of turning this on for unprivileged processes. As soon as they do, we can turn it on in systemd, just like that. Maybe we don't actually have to change any line of code. But yeah, so would love to support that. The desktop people have asked me about this too, like the GNOME people that would like to do that for the sandboxing that they do for Flatpak apps and these kind of things. But yeah, it really depends that the kernel people accept this and make sure that this is secure and then turn it on. Any other questions? Nothing? Okay, let's go to the next topic. Oh yeah, well, I mean, let's talk a little bit longer about this still. So C groups actually are organized in tree, right? It's not a flat thing. You can actually say, basically, you can have one root C group and then the child C groups of that and child C groups of that and so on and so on. This is made use of for the IP firewalling accounting. It basically allows you to say, for the entire system, you specify one firewall, and then for specific services, you exclude them from that, right? Both negative and positive. So yeah, you can, to some level, replace classic IP tables with this. But this one is it's much more reduced in the feature set, and there's no intention of us to ever get into the same business as IP tables is there, because IP tables has all these modules to do magic stuff with packet matching and things like that. We don't really want to do this. We want to keep a focus on keeping the minimal things in place. Like, for example, it currently doesn't even support matching per port number. The reason for that is simply philosophical, because after all, if we have per service matching, we don't need per port matching that much anymore. We could totally support that. Maybe we will do that one day. But yeah, the idea is really not to create a second IP tables. It's the idea of creating something with a more focused use case, but a lot more dynamic and a lot more integrated with regular service management. Yeah, this is what I already showed you. Okay, so the next thing that I want to talk about is something we recently added. It's called Dynamic User. Dynamic User is basically, on Linux or in Unix, the quintessential security credential that we have is the user ID, right? Like stuff where 0 is root and 1000 is Lennart, and yeah. It is how Unix security was done since about always. And that basically means that like all the file systems, all the shared memory objects, basically everything that Linux kernels manage ultimately comes with a UID owner, right? Regardless how old the stuff is, how limited it is, the UID will always be there. All the other security concepts that were added to the Linux kernel came later, and sometimes they're available, sometimes they're not. Like, for example, SLinux label is not available on all the file system stuff. ACLs aren't. All the newer stuff is kind of this optional stuff that is widely supported, but not universally supported. The user ID, on the other hand, is really, really awesome because, yeah, everybody can agree on that. And not just Linux, all the other Unixes can agree on that too. However, user IDs were highly limited in their functionality because traditionally they're highly static, right? A package would, during package installation time, register a new user. Like, for example, you install Apache and there's the HTTP user being created. And then Apache will only use that one user. So they come basically at a price. There are only 1,000 system users available, and you can never really go and allocate 50 of them, because if you did, then there would be much less for everybody else. So yeah, and then the other thing is, of course, that they're only currently registered during package installation time and not thereafter. With systemd, we now added this dynamic user property. If you set that on a service, then user registration becomes dynamic, and the life cycle of the user registration you can bind to the life cycle of the service itself. This, I think, is a major step forward to building secure operating systems, because suddenly allocating UID becomes cheap, right? You can just do it on the fly. You can do it with systemd run, and I'm going to show you how that works. So basically, yeah, if you, it's a Boolean option. If you turn that on for a service, then when the service is started up for the first time, it allocates a user. This user is not written to etc passwd. It's just kept in memory, but it will show up in all the commands that do NSS. Like, for example, if you type get and passwd, you will see all the currently registered users like this. When the service goes down again, the user ID is released again. So yeah, you have this transient logic in there, and it's clearly lifecycle bound. The idea is that we integrate as much as we can with the lifecycle of a service, so that in particular there are no leftovers in the system after the service went away, so that you can basically fire up a service and can be sure that it doesn't leak anything on the host. But after the service goes down, everything is gone, except maybe logging about the fact that you just ran what you ran. Now, implementing dynamic user. That's a question. Sorry?
Is there a limit on the numbers that are max?
So the question is regarding whether there's a limit on the numbers. So currently we allocate by default, and this is compiled into systemd, from a very specific range, and that range is above 60,000 or something. I don't remember. I would have to look in the sources. But so we of course, the ranges are, like people use different ranges for different applications currently. The stuff that we currently use in systemd by default is the range where all the distributions that are out there generally can agree on this is not used for anything else, right? Surprisingly, even though the distributions vary wildly, there's one range where everybody can agree that this has been not used so far. This is, however, like some installations, some bigger installations do deviate from the distributions, right? They throw away whatever the distribution sought, where the LDAP range is and where the local range is and whatever else, and they just use any user ID. In that case, yeah, you will have like limited, much more limited set of user IDs available. We probably will make this configurable eventually, but right now, like my thinking is that how user ID ranges are defined is just really something that should be up to the distributions and not really to the administrators, right? Because the distributions, they are about integrating different kind of software, and if different kind of software wants different kind of ranges, then the distribution should make sure of that. But then again, we might revisit this. This hasn't come up before. Nobody had real issues with that, but I'm pretty sure, yeah, I mean, in the wild probably will eventually, and then we'll add it. So the question was whether the users are tied to the lifecycle of the process of the unit, right? So if you have multiple processes, actually not even just that. If you have 2 units that specify the same username for the units and both say it's dynamic, then the user will exist when the first one of them is started and removed only as the last one of those are stopped. That's a very good question. That's what I'm going to talk about next. So the big issue with user IDs is because the way they were originally intended to be used, right, that you register them once and then they stay around forever, is that user ID ownership of files is sticky, right? If I am user ID 5555 and I create a file, then this file is going to be owned by user ID 5555, right? Now, if I want to go for dynamic user IDs, I want to be able to recycle the user ID 5555. If I do that, however, I would suddenly get access to all the files that were previously created by some earlier iteration of that use. So to make sure that this doesn't happen, right? Like one option, of course, is we could scan the entire file system, remove that stuff, but that would be, of course, prohibitively slow, since I mean systems can be very large. So we're not doing that. What we're doing instead is services are by default locked. Like as soon as you turn on dynamic user and set that to yes, they are locked into a sandbox. That sandbox basically says you don't get to write anywhere anymore, right? With some exceptions. One of those exceptions is you get your, you automatically get your own like private TMP for, like, do you know private TMP? Like there's this feature of systemd that you can turn on for a service that basically means that the service gets its own private instance of /temp and /vartemp that is also lifecycle bound to the service itself. And that is basically, it's a subdirectory of /temp and vartemp that, however, is through bind mounts appears as being /temp itself, right? It's originally a security concept, so because it's one of the most well-known security holes all across our Linux ecosystem is always guessable file name use in /temp. And the original reason why we created this is to get rid of this entirely, because you just turn it on for a service and then there is no vulnerability anymore, because the names may be guessable still, but because you don't share the namespace with anyone else, you're good. Now, this option is automatically turned on for everything that's dynamic user equals 1. So you basically, by default, to get exactly 2 writable directories, /temp and /vartemp. If you write something there, it goes away when the service goes away too. That sounds very limiting, and it is limiting. The way out for that, so that actually services that make use of this can write stuff persistently to disk, is the other thing that's on the slide, the state directory stuff. State directory is something we added recently. It basically allows services to declare a directory under varlib that belongs to that service, right? Think about MySQL, varlib MySQL. if you, like state directory is generally viable if you use dynamic user equals 1 or if you don't, right? It's a nice way how you can combine these things because systemd will then automatically create it for you if it's missing. So you can create highly dynamic services where the entire unit file basically says what they're, like how it's supposed to run and what has to be created first. But it becomes particularly powerful if you combine it with dynamic user. Because if we do combine that, then basically we will provide you with a directory in varlib, and we will always guarantee you that this directory is properly owned by the dynamic user we had just allocated for the service that you're running. Now this sounds vulnerable because you still have a file, like a directory in varlib owned by these user IDs that go away. The reason why it's not vulnerable is because through some magic symlinking and bind mounting, we actually, it's like what shows up as varlib foobar is actually a directory called varlib private foobar, and the private directory is non-accessible to anybody root, right? So this basically takes a page from the book of containers, because in containers that's usually, I mean, they have the same problem, right? Like where if you log into the host system and you could see any containers that are located in varlib containers or some directory like that, right? Because the containers generally reuse the user IDs from the host. If you are user Lennart on the host, you could then access all the home directories of all users 1000 on all the containers, which is a big security hole. So their way out is that varlib containers is always readable to only root and nobody else. We do the exact same thing here. So let me actually, can I do a demo again? Let me show how that actually plays out in real life. Can you see that? Yeah. So if I run this, now I have a unit, and it has dynamic user equals 1. So if I do ID, I see that I got the user ID 64238 assigned. Yeah, if I do PS, then I see my own process there at the very end. Because the user is a little bit long, PS truncates and puts a plus there, so don't. Yeah, I don't know exactly how to get PS to not do that. But yeah, it's properly registered. Yeah, and if I try to write something anywhere, I couldn't because, yeah, I don't have the rights to, but if I do that in temp, first of all, I get my own private temp, so it's going to be empty, but I can do something here, and it's owned by me. And if I go away, then it's gone away too. If I now run the same thing again and do ID, I got a different ID. Like, anybody remembers the old ID I got? Where is that? Yeah, my old ID was 64238, and now I got 61385, right? Now, because we don't use state directory on this one has no chance to make any persistent changes, right? Let's now change this command a little bit. We use -p and do state directory. Let's call it something I can remember, z. So I've got a new user ID again. But now if I go to varlib I got this private directory here. And if I do something here, and then I exit and I run this again, and I go to the directory again, the files are there, right? So you know what's interesting though? Is that I actually got the same user ID as I got before. I didn't show the user ID of the run before, so you can't actually see this. This is an optimization, the fact that it gets the same user ID. Because we, like, let's say user IDs are recycled, right? Systemd will go recursively through varlib z if the user ID is currently being used for something else, right? Because it needs to make sure that nobody else gets access to these directories. So basically what happens if a service starts up and you specify state directory equals something, then you get your own varlib directory. If that already exists and is owned by a user from the dynamic range, we try to use that user ID if it's currently unused otherwise. If we can reuse it, we're happy. We don't have to do anything else. We just start the service and are good. If, however, there is something else running under that user ID, some other unit unrelated that also uses dynamic user, then we will recursively chown the directory to the unit, to the actual user ID that we're now using. So yeah, ultimately, like the takeaway, I mean, this is a little bit ugly, the fact that we do have to chown that. Effectively, chowning recursively is surprisingly fast in all modern Linux file systems, so it's not too bad. I'd love to solve that differently, though, eventually. Anyway, but the takeaway really is if you combine dynamic user and state directory, you have this awesome way of sandboxing stuff in the traditional Unix way, right? Because it's all about, around user IDs, but fully dynamic and with writable directories in var lib. There's also, by the way, there's not just state directory. There are 3 other, or 4 other settings like this. There's cache directory equals something. If you use that, you get a directory in var cache, and the same stuff happens. There is logs directory, and you get a var log thing. And there's runtime directory, where you get something in /run. The runtime directory operates a tiny bit different, though. If you use runtime directory, then the entire thing goes away the instant your service shuts down. This is reflects the way how /run works, because it's supposed to be used for runtime stuff only. You had a question.
What does varlib ZZZ look like when the service is running outside of the unit and after the service exits?
Okay, so the question is, how does it actually look like right now? Like the ZZZ directory that we created for this service. Let's open a second terminal. If we go to varlib, you'll see the private directory here, like this one. So this is basically the directory that makes sure that whatever like the dynamic assignments are, that is not visible to the host. What's important to notice is the fact that it's only accessible to root. And if you then enter that, which I can't, of course, because I'm Lennart right now, but let's become root. If I enter this, yeah, you see basically all my experiments that I did on other talks, but the most relevant is the one at the bottom, right? So what you see right now here is a couple of these directories have owners that it cannot translate. That's because there's no dynamic unit currently running with this, so the user ID mapping is not used. This one, however, is running, right? That's why you get a pretty name there. So that's how it looks like. Does that answer your question? There's another question.
Kick off 2 units at the same time with the same state directory. Like kicked off 2 at the same time with ZZZZZ.
That's a very good question. So the question is, what happens if you start 2 units at the very same time with the same state directory? This is currently not supported. If you do, there's no locking applied. It's your problem. We will probably we will add some kind of locking there, and then if you start the second one, it will just say busy or something, use a different directory or something like this. But we might also support eventually that if everything matches, right? Like if you get the dynamic user and if the name to use for that user, which is, by the way, is configurable. Right now, you always get the automatic assigned name, but you can also configure it to something else. So if you do have services, if you do have 2 services and you would specify the name for both and make both dynamic, and then also use the same state directory, then we could support that, of course, right? If that differs, of course, we can't. But
That sounds really complex, especially because you said there are 3 possible directories you can supply.
it's actually not that hard.
Well,
It's
so if they have the same state directory but a different cache directory, what happens then?
yeah, I mean, eventually we'll say busy, right? Like, but that's really up to you. I mean, yeah, you can build arbitrarily complex stuff with this, but I think in general it's super, super simple to use, right? Like you just, yeah. This also, by the way, enables awesome stuff because it's available for instantiation, right? So let's say you have a service that uses socket activation, and for every incoming connection, a new systemd instance is started, right? And then you can use dynamic user equals 1 for this, and basically give every connection that comes in a different user ID, and so you can nicely isolate the incoming connections from each other and be sure that they can't exploit each other. Because that is traditionally a problem with init if you do per connection forking off, right? Like even if you drop privileges, what hopefully most Unix services do, and you do not use the dynamic user stuff, then you have the problem that if one of them is exploited, it can p-trace all the other ones and get all the data from all the other people who have currently connected. So yeah, it opens a lot of other things. Like for example, you can even use it to put together a pipeline, like a Unix pipeline, because you can do systemd run --pipe, and then you use -p dynamic user equals 1. And then you can make this systemd run invocation part of any pipeline you like. You can pipe something into it. You can pipe something out of it. But this thing that you have in the middle is nightly sandboxed with its own user ID that goes away as the pipeline ends. And of course, you can awesomely combine them with all the other stuff, with memory accounting, with IP accounting, with IP firewalling. So it's really, I think, to me at least, I mean, Unix, difficult and stuff, but I think it opens up so many new possibilities in a very Unix-ish way because you can make it use of arbitrary pipelines that you like. And sandbox, in a way, how I think we should always have done sandboxing in Linux by using user IDs, right? In a way, this, by the way, is not new, right? Like, I mean, Android, the apps on an Android phone, they're all separated out by user ID. This is just our attempt to make user IDs as, I mean, we are more dynamic now with this than Android ever was, but the idea really is that, yeah, user ID are awesome, and people should use them because they are the best way to isolate stuff on Linux.
Is there any support for other resources keyed off of user IDs, like System 5 shared memory settings, things like that?
So the question was regarding the interaction from user ID, like the dynamic user stuff, and System 5 shared memory. So yeah, the logic right now is like System 5 shared memory is, like for those who don't know this, like the System 5 shared memory is like this awful way of IPC of Linux. And it's a little bit like the file system, but it's not the file system. But you can also create objects there, and they stay around, and they're owned by the process that originally created them. If you use dynamic user equals 1, then the life cycle of these IPC objects, it's also bound to the service's runtime. So basically, it's a little bit ugly, I would say, but basically you get something, you start the service, and then you can create as many IPC objects as you want, but as the service ends, all yours will go away. Of course, removing something reliably is always a little bit like, I mean, there might be SLNX or whatever prohibiting that to us. So there's another check built in, actually, that if there's at least one IPC object owned by a dynamic user ID, we will not use that dynamic user ID ever to make this fully secure, right? It's ugly that we have to do this, but Linux is the way it is. But yeah, it should be, like, at least to my knowledge, it should be comprehensively secure, right? Like at least all the resources that I'm aware of that we have on Linux where the sticky user ID problem exists, we took care of.
Is there a recommended way of doing logging using the system?
Sorry?
Is there a recommended way of doing logging?
Logging?
Yeah.
So the question was regarding whether is there a recommended way to do logging with this stuff. I mean, in system in general, we have this journal component, and that is our way how we think logging should be done. And it implicitly, everything that you run with systemd as a service gets is std out and stdr connected to the journal, as well as all its syslog traffic also goes to the journal. And the journal then takes the information that it gets, all the stuff you logged to output or to syslog, whatever you have, will attach a lot of metadata to it about what process is actually doing what PID, what user ID, and so on, and writes that to disk. All right? If you use, however, systemd run-t, like how I just used it, you can still see that, yeah. Right now I used -t here, which gives me the TTY. In that case, std in and std out of bin bash goes to me, right, like as a user. If I would drop that, I would run the bash in the background, and whatever it prints goes to the journal, right? And then you can pull it out. Like, I mean, let's just do this. So we have this little service here now that I'm creating on the fly. It just runs systemd run through systemd run and just calls back echo and says foo. And if we do this, then it will ask me for my password. Shit, now this is weird. Let's try that again. So it ran and it logged something, and if I now use journal control-e, I see that it wrote that at the end. Systemd, this is the output that is resembles classic syslog, but there's also this mode where you can do this, and then we go to the very end. Yeah, this is the longer format what's actually stored on disk, and then you see like the foo message, and that the process is echo. You see the C group information, which unit that precisely was, and lots of other stuff that's not super interesting. But yeah. that's your answer, hopefully. But this is nothing new, right? Like I'm mostly focused here on new stuff. The journal stuff has been around for a long time, right? Let's return to the slides, maybe.
Just one quick question. What happens when you run out, if you somehow run out of dynamic users?
Then the service will start failing. I mean, there's always reasons why services can start failing because you don't have more processes anymore, no memory, whatever else, and no more user IDs, it's just one more. Yeah, but I mean, the range is not overly large right now, right? Like, the thing is that on Linux, we in theory have 32 bits for user IDs. In practice, that's not really the case if you think containers and that kind of stuff. So it's probably safe. And there are a couple of older file systems, like until Linux 2.2, user IDs were 16-bit, right? So it's probably by default, it's because of the NFS and these kind of things still have 16-bit file UID support. It's probably safer not to use the full range. So, and that's why systemd won't do that either by default. But again, we can make this configurable, so you can go for the full 4 billion if you like, and if you need. Yeah. I basically talked about all of this. And yeah, you saw this too. Okay, next one. Assuming that nobody had a question about those stuff that I was talking. This one is a simple one. This has come up a couple of times. When people write services for systemd, they sometimes want to embed information for whatever is supposed to be processed there inside of the unit file itself, right? Think you write some kind of job engine and you want to run something in the background as a service. And then whatever that job's supposed to process, you want to embed that directly in the unit file so that you only need one unit file to describe the entire command line, what it is supposed to process, and how it's supposed to run, right? We recently added the standard input data and standard input text settings to systemd. What this does is very simple. Standard input text, you just specify text. You can use it a couple of times to specify as much text as you want. And this is simply passed into stdin of the process started. And then standard input data, kind of the same thing, but it's more focused about binary data. So what you specify is base64 encoded stuff. You can use it from the command line as well. I'm not going to show that to you now because I am too lazy to generate the base64 and stuff like this. But it's super simple. It basically allows you really to, the idea really is that people write their job executors in a way that they get their data, what they're supposed to do from stdin, right? Think, for example, you write something that is supposed to process images or something, and then it gets a JSON stream from standard input, which tells it which files to process and to what to do on this. And then you can encode that right in the unit file, and you need nothing else anymore. And because in systemd, what's really important to us really is that ideally, all the jobs that you run don't leave anything around in the system. Like this is why we have dynamic user, for example, because they will go away as you shut it down, and because we have all the sandboxing so that the stuff can't write anything to anywhere, and that we can bind the IPC objects and we can bind the temp stuff to the runtime of the services. So it's kind of nice having this. What internally happens if this is done is there's a memfd created for those. Like memfd is like this kernel concept where we can have like a bit of data and get a file descriptor for it. And that's really all there is to it. It's supposed to be a in-memory file descriptor thingy that stores data for you. Any questions about this?
So the base64 data is automatically decoded, right, when it passes through the processor?
Sorry?
The base64 data is automatically decoded
Yep.
before it passes through the processor?
Yeah, so the data is like whatever you specify in the unit file as base64. When systemd parses a unit file, it will decode the base64 stuff and store it in binary in memory. It will already create the memfd. It just, when the activation happens, it just passes the file descriptor over. So base64 is nothing that your actual code needs to know about. It's really just about the way how it's kind of, like I guess it's how people agreed to embed arbitrary binary data into other text stuff, regardless if it's JSON or our unit files. Anything else about this? Otherwise, I go to the next topic.
Actually, so the standard input is normal Unix-like line encoding, right? Nothing like,
So
those conventions and stuff like that.
So the question was regarding line endings, if we use this stuff. So if you use standard input data, right, you basically specify binary stuff, right? Like, and it's completely up to you what it, like if it's text, it doesn't have to be text, it could be a JPEG file too, right? But if it is text, it's completely up to you what kind of line endings you use. If you use standard input text, however, which basically where you just literally specify a line and then you can do standard input text, another one, another line, then systemd will concatenate the \ends and assumes that everything's \n. So standard input text is probably good if it's really just a couple of lines you want to input. But if you want to have anything more complex and you actually care about like binary identity, that it's actually exactly the binary bits that you want, then use the other one. Yeah, here's another one that's actually pretty useful. Or actually, how much time do we have? Maybe this is one we skip if we don't have time that much. What time is it right now? Where's Brian? I guess we have plenty of time. Okay, so this is a pretty simple one. What this does is that for a specific service, it will mount something as a temporary file system, as a little bit of scratch area. So you can basically specify a path, and if you do, then that path will be replaced only for that one service by a tempfs instance. So it's a way of sandboxing stuff that we recently added. I mean, there's already all kinds of sandboxing in place in systemd like Ref. For example, protect system, which is one of the most interesting ones, which basically allows you to say, for this service, the entire root file system shall be read-only. And then the only stuff it may access is /var, basically. It's actually something that the dynamic user stuff uses. This is relatively recent, which we added on top, which is one way you can use this is also protect home, which is like protect system, but protects /home. And you can replace it by a tempfs, so you can basically even have a service that wants to be able to access home, but you can still give it its own instance of /home, where it can do whatever it wants to do without affecting the host. The most important thing about this, though, is that it allows you to hide intermediary paths in the file hierarchy. The background of this is in systemd we have a read-only path and inaccessible paths already. So if you specify inside of a unit file read-only path equals /etc, then this basically means, yeah, for that service, etc shall be read-only. You can also specify inaccessible path equals etc, and in that case, it would be replaced by only for that service, it would be replaced by a directory that is entirely inaccessible and empty, right? Inaccessible meaning that all the access bits are taken away and things like that. This one is particularly useful if you combine these things, because it basically allows you to, for example, say temporary file system equals /home, and then say read-only path for some subdirectory of /home. So, and then you basically get the subdirectory of /home that is readable or whatever else you want, but everything else in that directory is going to be replaced by an empty tempfs. You have a question?
How is this accomplished? Is it accomplished by intercepting system calls, or is it accomplished kernel assistance?
So the question was how this is accomplished on the lower level. It's file system namespacing. It's it's like Linux, the classic way of doing file system namespacing, and then it's bind mounts and all this kind of stuff. It's basically what containers do, but it's different than what containers do, because containers generally create their own environment from this, right? While this one is really focused on recreating as much as possible the environment of the host with some exceptions, right?
For debugging, it's often useful not to have these tempfs go away when you're exiting the service. Is there a way to tell it to copy and back it up before it exits so you can see what the bits were that were
Yep.
over and crashed, let's say?
So the question was regarding, like, it might be useful for some cases that the temporary file system doesn't go away when the service goes down. In the current implementation, it will always go away. My recommendation, if that's what you want to do, is probably to mount the temporary file system first with manual commands, like mount, like bin mount, and then use bind mount. No, it's called just bind pass, sorry, which is another, has been around for a while in systemd that basically allows you to mount any directory on the host into any directory from the view from inside the service, right? So yeah, the idea would be create it first wherever you like, then use bind pass to make it appear at /home for that one service, but not for anybody else. And then when the service goes down, because the bind path does not imply that the file system is destroyed. It just means that it's about visibility. It's not about destroying or anything. Anything about this? Otherwise?
Could you use DD to copy the temporary systems?
So the question was regarding whether DD can be used to copy the temporary file system. On Linux, TempFS file systems are proper file systems. They're not backed by a block device. And because they're not backed by a block device, DD is not really viable for that. But you can, I mean, there's rsync and stuff like that, right? Like something that operates from the file system level, that can be used to copy in and copy out. I mean, it's a regular file system after all. Okay. Something that we recently added that's kind of cool is these two mount options. You know /etc tab, right? Like everybody knows. I'm not going to even ask if anybody does not know /etc tab. But we recently added these new options, xSystemd makeFS and xSystemd growfs. And maybe you can already guess from the name what it does. It basically tries to cover this typical use case. Let's say you have like you built a image for an embedded device. And usually embedded devices, you start with, you want to deliver the initial image relatively small, but then as you copy it on the SD card, you want to grow it to the size of the SD card, right? And you know, that's not only the case for embedded stuff, you usually want something similar for VMs, right? That the initial VM image that you deliver to machines is small, but then as you click around in your VM UI, you enlarge the hard disks that it's used on, and then you want to automatically resize the stuff when it boots up. In System, we added these two things that basically allow you to say, like, it's just a simple fstab option. If you specify that on a file system, if you specify xSystemd growfs, for example, on the file system, then all it does is that when it notices, when it's about to mount the file system, that the file system is smaller than the partition it's on, then it will automatically call like the right ioctl, like the right kernel API, to grow the file system so that the partition and the file system size match, right? And then makeFS is kind of the same thing, but the thing is automatically formatted if we notice that there is the partition, but it does not contain a disk label yet. So the idea basically with this is, I mean, what it's not going to do for you is repartition your hard disk, right? It will assume you already have done that, but it will fill it, like it will enlarge the partition, the file systems on the partitions as makes sense with the partitioning that you chose. Now, you laughed about the repartitioning stuff. We probably want to add another component that allows you to do some minimal kind of automatic repartitioning at boot if, like, basically that you can specify constraints like that there should be at least 2 copies of the root file system around so that you can do this AB stuff, for example, or that there should be a home partition, and if there's not, create one. So the idea is that this new component would create the partitions, and then these 2 options will resize the file systems or create them in the first place if they're missing. This automatic tool, of course, like this too is completely optional, right? Like if you don't want to use it, don't use it. But we realize like all these scripts like all the distributions we currently have different implementations of growfs around that do implement this, and we saw like these are usually horrible shell scripts, and they are really not very careful with partitioning your system properly in a safe way that you can turn off this thing at any time. So we figured this is something we should probably take care of in the core operating system, because at least I personally believe this is how operating should be delivered, right? Like that you, like if I install Linux on my laptop here, for example, it should just copy some initial image on my onto the, like DD it on the hard disk, and then the first time it boots up, it should resize it so that the full hard disk is used. So I think, yeah, and you will want to use it for VMs, you want to use it for embedded, and I think even for desktop, so we figure we should just add this, and then people who want to use it can use it. That's the question. So the question was about whether there should be something dynamic allocation of swap partitions and swap files. I mean, probably the name doesn't suggest it, but if you specify xsystemd makefs on a swap line in etcfs tab, then we'll actually format a swap partition in it. It's like the partitioning thing will allow you to use that too. So there's not going to be anything explicit for the swap stuff. It's just a corollary, like an effect of the fact that we can do this for file systems. And Linux, in many ways, considers a swap partition the same thing as a file system, right? For example, by listing them in etcfs tab. So yeah, we probably will have this. Swap files, though, I'm not sure. Like, to me, it appears that swap is kind of on its way out, right? Like, there's some people who believe in it, but I think it's mostly a religious thing these days. But I don't know. There's memory management people here. Like, they probably can tell you if you still should do swaps or not. But you should? On SSDs, you should? Okay. But I'm not sure. Like, yeah, we have to figure that out. It's the swap file thing hasn't come up so far. And yeah, the proc partition thing we will cover with this. Any other questions to this?
Yeah, does that only work in FSTab, or is there a provision to do that in a mount unit as well?
So the question is if this only works in FSTab, or is there provisions to do that in regular mount units as well? A little bit of background in systemd. We only operate on units. And there is one type of unit, which is a mount unit, is how we actually do mounts, right? And so that we can order them against fscheck and the other services. So growfs and makefs are simply two other services like systemd fscheck. There's systemd growfs and there's systemd makefs, and they are little more than magic wrappers around the right makefs binary commands or around the kernel ioctls in case of growfs. So these services are there. If you use mount units, it's a little bit more work. You just have to basically pull in the growfs or makefs service and order yourself after that, right? So it's totally viable, but I mean, FSTab is simple and it's not idiot-proof, but it's much simpler, right? Like, and so you get this one-stop option to make use of this. But I mean, ultimately, what we do is we translate FSTab into units anyway, right? Like, so ultimately, it's always a unit. I hope that answered the question.
I think we like mount units, though, because then you don't have to go mess with FSTab.
Yep.
Is always a pain.
But totally, like if you want to not touch FSTab and you want to, like for example, be able to package mount units in an RPM or something like this, so you want to drop in files instead of modifying files on disk, then totally you can use this unit that is there. Any other questions about this? Otherwise, I'm going to jump to the next thing. Yeah, let's talk about what's coming next. So much about the stuff that, like everything that I talk about right now is already viable, right? Like it's made me not viable if you're running something like RHEL 7 because that's too old. But if you run something like a current Fedora, you have it. You can play around with it. Yeah, let's talk a little bit about what's coming next. I think I got like a half an hour or something left at this point. Let's skip over this. Let's focus on this. Portable servers is the next big thing that's coming. The PR is currently under review, and it's going to be merged in the next weeks. Portable services is something that we came up with taking a little bit out of the book from containers and applying it to regular service management. Specifically, you know, if you do container, like nobody knows really what a container is, but generally it's accepted that container is about bundling files together, like resource bundling, and sandboxing. Right? Then that said, like other than that, a container is mostly marketing terms, so nobody knows what it really is. But these are probably the two concepts that most people can agree on. There have been attempts to make like container management useful for extending the host system. Right? Like for example, I know inside of Red Hat we have storage people and they want to do their storage management stuff and ship it as a container. To me personally, this is, and for them too, this is problematic because as soon as you manage system level stuff from a container, you have a problem because it's sandboxed, right? So if you want to do a system level stuff, if you want to access to local storage devices, if you want to have access to def SDA, if you want to have access to all the kernel storage APIs, LVM, DM, all these kind of things, then you're breaking the sandbox. So they came up with this concept of super privileged containers, which is basically, oh, let's use containers and then turn everything off that makes up containers. Yeah, they ran into problems with this, and like this idea I find really, really strange. So our approach to do something about this is called portable services. So if you think about that, like if you have an axis of isolation versus integration with the system, right now, let's say on my left, we have fully integrated stuff like a system level service, right? Like classic systemd service. And then on the other end, you have VMs, like fully isolated stuff that more appear like their own virtual systems, right, where communication only happens through the network as if it was a completely different thing, physical thing. And then you can put containers somewhere in the middle, right? Nobody knows exactly what they are, so probably not a point on this thing, but a range. With portable service, I want to put something that is between containers and the fully integrated stuff and gives you resource bundling and a strong focus on sandboxing, but is otherwise just a regular service like everything else. Something like this existed on Unix since about ever. It's called true-rooted services, right? If you ever run something like postfix, I think postfix true-roots itself. Or Avahi, you know, this MDNS zerocoms thing that I wrote once upon a time, it's actually internally also true-roots itself. Portable services are basically that, though a lot more useful and more usable and more automatic, and it's a way how I think that true-roots can be made useful for many use cases. I'm not saying that portable servers are the solution for all your problems. They are definitely not, right? Like there are reasons why you want to use containers, like if you want to deploy it in big clouds and things like that. Portable servers is supposed to be something where, yeah, for some cases like where you need privileges, it's the right choice. For others, it might not. It's completely up to you if you want to use it. So, yeah, portable servers are resource bundling and sandboxing much like containers, but it's otherwise a regular system service. Let's talk a little bit about the concepts, how portable services work. You have an image. An image is something, an image, we're going to talk about that a little bit later, is basically just, the bundle, the resource bundle, like where the files come in, like something could be tab or something like this. And you attach the image to the local host. And this makes available the units included in that image to the host. And then you can start them and stop them, whatever you like. They are, at that point, completely regular system units. And when you don't like them anymore, you detach the image again, and the units are gone. Nothing is left in the system, right? If we talk about images, it's either directory or butterfly subvolume or whatever you want, or raw disk image. A raw disk image meaning something like something that you can loopback mount, right? Like something like that has a GPT partition table or maybe not, and has a file system in it, right? It's, both of these are basically two concepts how an image, like how you can ship files in a way that the Linux kernel natively understands it. That's a question about this. From what? So the question is, how is this different from systemd import D? Systemd import D, we probably hooked that up, but systemd import D is just like a tiny component of systemd that is supposed to make nspawn containers nicer. But portable services are different from nspawn containers because nspawn containers kind of focus on system virtualization, right? The idea is that what you run in an nspawn container is very much like a regular system, except like it's more like KVM in many ways, right? And this stuff is really like focusing on services, right? And most likely import D is something where we that we'll be able to download both images. But yeah. So because it's a raw disk image, it's hooked up into all the nice stuff that the Linux kernel supports for raw disk images, for example, which is dmverity and LUG. So you're going to get crypto and verified images that basically stop working if somebody who doesn't have the right keys modifies them and things like that. But again, you can also just use a regular directory. And attaching an image is basically, like, let's talk about the actual operations of attaching and detaching. Attaching an image is basically, it's super simple. It's just look at the image, copy out the relevant unit files onto the host, basically to etc systemd system, and there they are. By default, it will derive the units, a unit, like an image might contain many, many units, but only some of them should be copied out. By default, it will derive what to copy out from the name of the image itself. Like, let's say we have an image called foobar-4711.raw. then this basically means we will truncate everything after the dash and then copy all services that match foobar out of the image. It's very simple in that regard. You can, however, specify any prefix you like. This is just the default to make it easy, right? After we copy them out, we augment all the service files with either root image or root directory. Root image or root directory are settings that have been around the system for a long, long time. They basically are just the chroot thing, right? Like, they basically to allow you to run a service, but specify a different root directory for that service instead of the host image, in host root directory. And root image is much like that, but instead of specifying some directory, you specify some raw disk image that is mounted, or a block device even. So basically, yeah, one is ultimately based on bind mounts, like taking an existing directory from the host, making as the new root of the service, and the other one takes a disk image and mounts that. It's in the kernel, there's not much different of the operation when we expose it to different settings. So yeah, it's augmented with that. And then optionally, it will also add, like, the augmentation happens via drop-in file. For those, like, I hope that most of you know what a system unit drop-in is. It's basically in systemd we have this concept that instead, like, if you want to change a unit file, if you want to add an option or remove an option, and the recommended way how you do this is you don't actually modify the unit file itself, but instead you create a drop-in file, which is basically something like a file that you drop into a directory that is named after the unit.d, right? So if you have foobar.service and you want to extend that, you create a directory foobar.service.d, drop any file in there that you like, and whatever is in that file overrides the settings of the main unit itself, right? It's the main way, like if you ever dealt with systemd, that you should have come in contact with that, because it basically allows you to, that if the vendor gives you one unit file, then you can modify it, and you are not disconnected from the changes the vendor makes in future updates of his RPMs, for example, right? So we use these unit file drop-ins, first of all, to create the root image or root directory mapping, so that we make sure that when the unit is actually started up, we use the root directory of the image that we're operating on. And then second thing is it creates a drop-in, which is supposed to, we call it a profile. It's mostly about security restrictions. The idea basically is in systemd right now, we have a lot of security settings. And we can't turn them on by default for compatibility reasons, because systemd didn't have them initially. And if we would turn them on, like for example, the stuff that the root file system becomes read-only, if we would turn them on by default now, if we would make them opt-out instead of opt-in, then this would break a lot of the existing services. Hence, we can't switch that. However, for portable service, we say it's a new model, so we can change this. And the way how it's exposed is through profiles. Profiles, the idea is that you basically have the choice between 5 different levels by default, but you can actually define your own profiles. These 5 things are just what we provide by default. Like there's one profile for like which is the default. One is do not apply any kind of security. One is apply every kind of security that we have, like dynamic user and stuff like this. Which one you want to use is completely up to you. If you use the completely unrestricted one, we have full integration with the host environment. So that's, for example, if you want to do what the storage people at Red Hat, for example, wanted to do, that's the way to go. However, if you want a little bit of isolation, you can use the other profiles. Yeah, and then we reload the service manager, and that's it, right? This is what the attaching operation is. The default profiles that we ship are trusted default. No, did I say 5? I meant 4. Trusted is basically the one where no security is applied. Strict is where the most security is applied. Default is something that I deemed like a good default. And then no network is exactly like default, but the network is turned off via the IP firewalling stuff that I talked about in some other ways. Let's make this more specific, right? Like what I just described was generic description of the algorithm behind this. Let's say we now have that image. So the first thing we do is we copy from the image, right? User lib system foobar.main.service, like under the assumption that foobar.raw is how the image was called, and copy that to the hosts etc system foobar.main.service, right? We just copy it out from inside the image to the host to etc. Then we create this drop-in. This one is the one that says root image equals or root directory equals, and not much more. Then we symlink, which is as much, we could also just create it, a symlink that basically links this profile that I mentioned into this. In this case, the default profile is used. And that's it. These three simple operation is what portable control attach foobar does. Portable control is our primary tool interfacing with this. It primarily has two operations, attach and detach. And yeah, you just specify the image name. Yeah, after you attach it, you can start the thing, and then you can stop it, and then you can detach it again. There's nothing particularly fancy about all of this. What I like to really emphasize about this is this actually doesn't add anything to systemd itself. It's completely implemented independently of PID1. There is no new option that we added. It's completely, like it just takes benefit of all the functionality that we have for service management in systemd already, like the root directory stuff, the root image stuff, the sandboxing stuff, and combines in a new, nice way. It's also, like, I mean, what's also really important is I don't define any new format for this, right? This just makes use of the fact that directories with operating systems in them or raw file system images with operating systems in them are widely established. It also takes effect of the benefit that for every service that we generally have on Linux, we already tend to have a unit file, right? So I basically built on the fact that disk formats and unit files are all very well established already, and so I get away with not defining anything new. The only thing that I really do is just, yeah, name the stuff in a way if you want to be nice, but you actually don't have to, so that the image and the unit share the same prefix.
Do you also create /dev directory, or?
So the question was regarding what about /dev. /dev is handled by default depending on the security profile that you use. If you use a trusted one, you get a bind mount from the host dev, right? And then you can, like, this is what you need for the storage stuff. But for all the other profiles by default, they just turn on private devices equals 1, and private devices equals 1. Like, it's one of the really old security features in systemd. It basically says that whatever runs there gets its own instance of /dev. And inside of that thing, there are not going to be any physical devices. Like, there's not going to be dev SDA. There's not going to be sound card device nodes or whatever else. The only stuff that's going to be there is dev0, dev null, dev random, dev urandom, and a couple of others like that, like which are pseudo device nodes. They don't refer to any real device. They are just a weird Unix API, right?
So for the trusted profile, I mean, there is no restrictions. You're sandboxing, but not really.
Yeah. So basically, it's completely up to you. You will, by default, see most of the stuff from your image instead of the host. But the idea is then, yeah, you have unit files. So use bind path, like the existing stuff, how you can bind stuff from the host into your service to make stuff whatever you like available, right? So it's completely up to you, and it's emphasized that that's up to you. But for the /dev stuff, we will, by default, link in the host thing, because we think if it's trusted, then it's trusted. So you should have the full access. So much about the portable services stuff, actually. This, as mentioned, it's currently in review, but it's going to be merged in the next 2 weeks or something, right? And then there's going to be portable control. Yeah, the really important thing that I want to underline, though, yeah, it does not anything conceptually new. It's like, you can say it's a reimplementation of chroots in a much nicer way, a much more automated way, and no new metadata formats, no new nothing. What's also interesting to know, by the way, is that with this, it is possible to create an image that you can boot in a KVM, that you can boot in nspawn, that you can attach as a portable service, all at the same time, right? It can be the same disk image, right? Like if you have a disk image that includes a bootloader, you can boot it in KVM. If it also if it includes only an init system, you can boot it in a container. If it doesn't include that, you can even attach it, still attach it, right? So yeah, this is really the takeaway. It's completely generic. It's nothing new. It's just a new way to package up the stuff we already had, and putting a new label and a little bit more integration on concepts that have been partially on Unix since 25 years or something. Any questions about this?
Do a prime function with this? You know, have it run only at a certain time, or?
Time?
Yeah, time function, prime.
Okay, so the question was whether you can do like time-based scheduling with these kind of things. Yes, you can. So portable services, they can contain most of the unit types we know. And unit types, there are socket units, there are service units, there are timer units, and there are .path units, and there are a couple of more. Most of them you can just stick in a portable service. So the idea is really that if you want to have a portable service that runs, like is triggered every now and then, you're welcome. Just put the .timer unit file of your choice in there, and there you go. So it's a little bit more generic in containers than regard, because containers, of course, can't do this, right? Like, because containers you have to start and then you have to stop, right? Like, they don't have any kind of other triggers that you can. But with this stuff, you can do socket activation, timer activation, you can do device activation, you can any kind of activation that systemd offers, because these things, after all, are pretty much in every way regular services, right? Like, after you attach them, they will show up in system control status, they will show up in system control start. It's all because they are native services. Any other questions about this?
How would one deliver, say, security updates for a portable service? Is that practical?
That's a very good question. Like, the question was regarding how to deliver security services with this. Ultimately, yeah, you would detach and attach, and there you go. It's completely up to you, by the way. The images, you can make them read-only if you want to. So then if you want to make persistent changes, you would use something like bindpass or state directory to get a directory on the host that is persistent while the image is read-only, right? This is the model that I would probably go for. So then you can do security update by simply stopping all the units in the thing, attaching the new one, but the data will still stick around. Or you can decide to put the data, the writable data, inside of your image, make the image writable at runtime, but then it's up to you how to do security, right? Like, it's a deal. I mean, this is not going to solve everything for you, right? Like, this is basically a building block. For example, it does not come with any way how you can orchestrate that stuff. And it probably shouldn't, right? Like, if you want to orchestrate something about on big servers, then use Kubernetes and containers and things like that. This is really something to be an alternative. I mean, you can use it for that, but you have to put together your own orchestration stuff for this. This is not going to solve everything for you. But yeah, my answer for the updating stuff is make your images read-only. By default, they are. And then just replace the image so that you have one golden image and the data stays on the system itself and is writable.
What's the primary problem you're trying to solve in development? So who is complaining, or who are you addressing?
So the question was running, like, who is this for? Like, the primary use case, I guess. I started with that. It's about because I've seen people like the storage people, for example, in Red Hat, that they come up with this concept of super privileged containers, which is basically for them containers that turn off all the sandboxing. So it's basically you take what containers are and you turn everything off and want the most integration into the host. And this is my approach how, like, if you need this kind of integration, right? If you don't want to live in your own world, but if you actually consider yourself a part of the host in many ways, except that you want to be shipped in a more nicest way and you want more fine-grained control about security, then this is the way to go. It's not, and I emphasized that earlier, it's not like a new idea of containers. It's not. It's portable services. It's not containers. So yeah, this has a different use case. It's for the more low-level stuff. But of course, it's generic. It's completely up to you what you actually use it for. And I encourage you to use it wherever you like. And if you want to use it in a container-like environment, knock yourself out. I don't have a problem with that. The use case that I care about, though, is to make stuff possible so that things that want to extend the host system can use it, so that the host system, so that they can reach a level of integration with the host that is not available with containers. So the question was regarding the profiles, whether there's a requirement to use them. Well, I mean, there's the profile that's called trusted. If you use that one, you don't get any, like it's empty. So you basically get no security, no nothing, but that's up to you. So there's no requirement, and this is exposed through the trusted profile, which is the no-op profile. Any other questions on this? I got like 10 minutes left, 5 minutes left, something like this. One thing I want to talk about is OCI compatibility. OCI, who has not heard about OCI yet? Substantial people. OCI is basically an attempt to do, like it's a specification for what Docker does, right? It's a container specification replacing the container format and execution environment of Docker in a way. It has been around for a while, and it appears to be this thing that everybody agrees on who does containers. In systemd, I personally don't think that OCI is the perfect specification, but then again, what is perfect? I have to acknowledge the fact that this is how people package their containers. This is how the build systems of the various distributions nowadays generate containers. So accepting that, I think it is kind of useful if the little tiny container managers we have in systemd, which is systemd nspawn, can just run this stuff natively. nspawn basically can do everything that it needs to do to support OCI. The only thing it doesn't do is read the OCI metadata format. The OCI metadata format is basically JSON blob that describes what to do. So what I'm currently actually hacking on is just adding support for that, so that basically with systemd onboard components, you can run OCI containers too, right? So this hopefully makes also very clear that portable services are not containers, right? Because we also will do something about the specific container support. Ultimately, my goal is really that, container stuff. As mentioned, nspawn does pretty much everything there, and then adding the little remaining bits so that you can run OCI containers is not that much work. It just means that parsing a JSON file and instead of a systemd.nspawn ini file and running that stuff. So yeah. And to me personally, this is interesting because cgroups v2 ultimately, because nspawn has really nice support for cgroups v2, and all the other Kubernetes, Docker, blah, blah, blah stuff does not. So if we just run everything with nspawn, then the cgroups stuff is basically under the systemd control, and we get cgroups v2 support automatically. So OCI is actually three things. Officially, it's a runtime spec and the image format spec, and then there's something that they're working on that is not official yet, which is the command line spec or something it's called. We probably will support sooner or later all three of them. I'm not sure that you want to use all of them to actually deploy stuff on big servers. You probably want to use Kubernetes for that, but I at least wanted to have, nspawn is something that probably it might make sense that you use on big servers eventually for running containers. But the other stuff, like import D that was mentioned earlier, I kind of want to add the OCI support for that because, if that's what people put containers on the internet, then maybe we should support just that. So we want to support all three specs, even though I'm not convinced that all three parts of that you should use for deployment. But you definitely should do that if you play around with containers and develop them, right? Because it's then just built in. You can just use them. You don't have to install anything. It's just there. Any questions about that? It's probably going to hit systemd very soon, too. The last thing I want to talk about is resolved. Resolved is this DNS stub implementation that we have with in systemd. It's basically it's a little DNS client that does caching, right? Like traditionally, does anyone not know what DNS is? Everybody knows what DNS is. Nice. So traditionally on Linux, the DNS client it was part of glibc. And so every single process that did a DNS lookup would do that in process, right? It would go on the internet, do its, put packets together, submit them to the internet, wait for the answers, and parse them. It would not, like, this is problematic, I think, for a number of reasons, and there have been exploits with this, because you probably don't want to do too much, like, packet parsing in every single process that you have on the system. And you also want caching, right? Caching in particular matters in today's internet because you have more complex RR types, particularly if you think about DNSSEC. So resolved was our approach because it's so basic, we decided to edit this to systemd, that we have a local, heavily sandboxed and caching implementation of a DNS client, only client, that runs locally. Then it would basically, like, it does a couple of other things that are nice. Like, for example, for myself, I work for Red Hat, and so I'm often logged into the Red Hat VPN, but I'm also in my local home network. And I want to be able to resolve both my printer's DNS name and the Red Hat internal DNS names. And that's traditionally really nasty because that's not how DNS works, at least if you use glibc. Resolved is supposed to fix all these problems because it can, like, it is designed with this philosophy in mind that it merges all the DNS information from all the networks that it has locally. So the idea is basically it will send a DNS request to all local DNS servers and all local networks that it is configured to in parallel, and then it will use the first positive answer or the last negative answer that it gets. So the idea is basically it will transparently merge the zones. Of course, if you have conflicts between these zones, you're fucked, but that's your problem then. But so it tries to make the best of a bad situation in that regard. So the big thing, like, I mean, resolved has been turned on in Ubuntu. In Fedora, it hasn't yet. That's mostly a political thing because, I don't know, I didn't want to fight the fights with the people in Fedora about turning this on. The big thing that's coming now is DNS over TLS. You probably heard about this, or maybe you didn't. It's like the next step. It's like, I mean, DNS was traditionally done with UDP, and nowadays there's DNS over TLS, so you basically do a TCP connection, do TLS on it. You keep it open for a long time, and then you have encrypted DNS. It's gonna protect you from, like, you still have to trust your DNS server, but it does protect you from people watching what you're doing. Yeah, and the patch set for that is already, like, we went through a couple of iterations with a review. It's going to hit systemd very shortly. In particular, as soon as you do stuff like DNS over TLS, because the model is that there's going to be one TCP connection per client that is left open as long as the server side permits it. We really need to have a local tiny daemon around that can have that connection open, right? You don't want to have these embedded DNS implementations that glibc provides you with because, first of all, that model doesn't work if you want something longer running, right? Like, it's like the model of NSS is something where you do one request, and then as that request is done, it's over. And yeah, security-wise, it becomes, like, because TLS is more expensive to do than classic UDP, you really want to keep open the connection and not recreate it all the time. So yeah, that's coming next. I think it brings like, yeah, it kind of opens us up for the first time that we can have this on Linux and hopefully will just work and everybody will live in a safer world. It is really complex to do because DNS servers are really awful in this world. And I mean, there have even suggestions to just ignore the local DNS servers and always go through Google or whatever people want to use. But this is problematic because, I mean, in company networks and even home networks, usually you do have private DNS names, right? Like, so foregoing the local DNS server in a general case is not really doable. And because that is the way it is, we have to deal with shitty DNS server implementations and stupid routers, and probably for a long time. So the complexity in resolved that there is mostly about probing feature sets and kind of remembering what the stuff it is that it can do, and then trying to make the best of a bad situation. That's the question.
How do you talk to it? Is it just an NSS module?
So the question is, how do you talk to resolved, whether that's just an NSS module? There is an NSS module, and that's a recommended way. But you have two other ways. One is going through a dbus API. And if you do, you get a lot of more information, right? Like, for example, resolved does DNSSEC. And if you are, like, glibc or NSS does not propagate the fact whether DNSSEC was successful or not, because, I mean, there are many cases where DNSSEC will not work. Like, on my shitty home router, it does not support DNSSEC, so I can try as much as I want. It will never give me a properly DNSSEC verifiable answer. So in ResolveD, we actually implemented a scheme where we will try to use DNSSEC, and if we can't, we will not fail, but we will just not do DNSSEC then, but we tell clients about this, right? So that clients know that this is DNSSEC verified or that it's not, right? And then they can figure out what to do. But this information we cannot transport through NSS. NSS doesn't support that. So if you use dbus, then you get that information. And the third API that we have is we actually listen on a local port. And then you can send DNS requests to that. And then we will translate that and do the stuff with merging the zones. And it also implements, by the way, MDNS and LLMNR, which are like this local zone stuff that everybody does now. Like if you have a stupid printer, that will definitely do probably both, which are like local name resolution without any central service. So it will hide all that, the fact that it does this in the backend, and give you just a port that you can talk to. But this is not a full DNS server implementation. It's just enough to make local clients work, because like things like Java and Go and like lots of these things, they don't use NSS because they think they're smarter than NSS and they want to do their own thing, and they don't care about Linux or the fact that there's more in this world than just classic DNS. So it's our way to hook up with that too. So that regardless what server code you actually have, you can route it through ResolveD if you want to. I mean, I would recommend you to, but you don't have to. And then you'll get transparent DNS over TLS, right? So your client can speak the dumbest version of DNS from 1989 or something, and it will still transparently get DNS over TLS in the backend with DNSSEC if you like, and the full feature set if you feel like it. Any other questions? Like, how much time do we have left? There are more questions. Does it work with anything besides TLS? Yeah, it's really, we spend a lot of time to make sure that it can deal with pretty much all the weird router DNS servers that there are. And I can tell you they're awful, really awful. I mean, there are some that you could just send the wrong DNS packet to and it just crashes and reboots, right? And through the testing that we got through Ubuntu, we nowadays are pretty confident that there might be still problems somewhere, but in general, we should be in a good position. But yeah, it will use the best thing it can do, but it will downgrade step by step to the worst thing that's necessary to make it work. Yeah, there's another question.
So where does this leave NSCD? Why have you never managed to get anything useful out of that?
So the question was regarding NSCD and how this relates to NSCD, I guess. NSCD, for those who don't know, is this. It's like a caching NSS thing that comes with glibc itself. It was originally created actually to do like for LDAP setups, right? Like because in LDAP you generally have to ask some central server, in particular for user identities. Not so much about the hostname stuff, but it's mostly about the user identities. And if you do an LS and you would always go through LDAP and TCP and whatever and talk to some central server, that's highly problematic. So they created NSCD. NSCD, as far as I know, is not enabled on any of the distributions by default. You can enable it though. For this stuff, I mean, it will do the caching for you, but it has, you know, the behavior is because it is written for what it's written. It has this behavior basically where it tries to talk, like the NSS, the NSCD client that is built into glibc will try to talk to NSCD, but will never wait for longer than 100 milliseconds as a protection against deadlocks with itself. For the reply, and if the 100 milliseconds pass, it will always do the NSS talk, lookups client side, which like defeats the sandboxing thing, right? Like if the answer can't be acquired in 100 milliseconds, I think my time's over though, what that's supposed to mean. Yeah, so because you have this 100 milliseconds time limit, it's not really useful. Like the DNSSEC stuff and the TLS stuff means it can take longer than 100 milliseconds. So, and yeah, I think they have a different use case. We looked into, when we started doing this, into making use of this, and in particular, like for example, re-implementing the NSCD protocol, and instead of using NSS. But because of these time limits that are through the entire thing, it's not usable for this. It's a different use case. So yeah, we try to do our homework and figure out how we do this best and if we have to do it at all. But NSCD is not it. I think this was supposed to mean that we had,
Yeah.
or do we have some more question time? Or
You
maybe
can ask maybe 1 or 2 more questions.
one or more, if anybody actually has a question. Like that's one question.
What do you think the biggest mistake in design?
The biggest, oof. There is of course none. The biggest one is probably, you know, in right now you have in system in PID1 these APIs that you can run services, like start them, stop them, reload them, restart them. But there's also the other set of APIs to enable, disable, and things like that. And we shouldn't have put that in PID1, but have kept it separate in a second service because it's different operation. Like one is basically stateless, right? I mean, it just runs on unit files that are already in the file system. And the other is about putting stuff in the file system, and it probably would have been a smart idea to not do that in PID1. But at that point, it wasn't clear to us it was all unit files. And then we had got a lot of pressure from people because they, I mean, initially the install stuff was client-side only, right? And then people said, oh, we want a proper API for this. This has to be among the other stuff. And then we said, okay, then we add it to the other stuff if everybody wants that. But yeah, we shouldn't have put it in PID1. We should just have a second service that is the installer thing. And no, but then again, I mean, it's probably too late for that now. It's not too bad. I mean, we, in all our time, we did not have any exploit in that regard in systemd. I mean, we had very few exploits. I mean, contrast what is reported on the internet, there have been very few security issues with systemd so far, especially compared with other projects of this size. So I don't feel too bad about it, but that's definitely something I would do differently these days. And other than that, I don't know, I'm not particularly well prepared about this question so far. Nobody asked. I mean, I'm actually surprised by the fact that nobody asked us this before, but they didn't. I don't know. There was probably other things that I would do differently these days. For example, sandboxing stuff. If I would start new, I would do opt-out sandboxing, absolutely. This is how you do security, and the fact that we can only do opt-in sandboxing is definitely a misdesign, if you so will. I don't know. I can probably come up with other stuff that I would do differently now. But generally, I'm actually kind of happy with systemd. It's it's not I know people who then after doing 5 years of their project, they step back and say, what the fuck did I do there? It's not like that. I'm still mostly happy with the quality of the code base and the general design. It has some warts, everything has. But generally, I think it's I mean, if you look at the Linux kernel, it has so much worse shit in it. So I don't feel too bad.
All right. Thank you, Lennart, for a very interesting talk and
Thank you
very
very much for having
informative
me.
talk. I hope you'll join us at the pub. We're all going to Storehouse Pub, which is on the northeast corner of 23rd and 6th Avenue. We will be, if anybody's joining us there, we will be downstairs in the back. Thank you again.